All right, here we are back at the midsegment theorem. And as we just discovered, the midsegment of a triangle, like for example DE in this picture, it is parallel to the third side of the triangle, AC, and it's also half as big. So let's take a look at some exercises. Example 2, the diagram shows an illustration of what else? A roof truss, where UV and VW are midsegments of triangle RST. Find UV and RS. So let's take this one piece at a time here. Come over here, second right on the screen, and we'll take UV first. So UV is a midsegment of triangle RST. That means it's parallel and half as big as this third side, RT. That means that this particular segment length should be 1/2 of 90, 45 inches. Boop. That looks good. Okay, and then likewise, let's change colors here. VW. So VW should be half as big as SR. So we want to find SR or RS, whatever. Okay. So this time, instead of taking half, it looks like we're going to double. So RS is equal to 2 times, boop, 2 times, looks like it's 57. 57 is the length of VW. So 2 times 50, that'd be 100. 2 times 14, 2 times 7, 14. So we got 114, also in inches. What would geometry be without roof trusses? Like, honestly, okay, let's go back to the slideshow. Example 3, use a diagram triangle ZY, XYZ, where U, V, and W are the midpoints of the sides. Part 1. If UV is equal to 4x minus 1 and YZ is 5x plus 4, what is UW? And of course that means how big is UW, right? Okay. So let's label some stuff on here. So we've got UV or UW being 4x minus 1. And then we have YZ, that's this whole third side of the triangle, is supposed to be a 5x plus 4. Okay, so this UV, I would have to double it in length in order to get the length of the 5x plus 4. Or I could take half of 5x plus 4 and set it equal to the 4x minus 1. I think it might be just a little bit easier to just double 4x minus 1 and set it equal to 5x plus 4. All right, and then distributing here, we got 8x minus 2. Get all our x's on the left-hand side, gives us 3 of them when we subtract. Add the 2 over, and then divide, we get x is equal to 2. Boop. All right, not quite finished here because it is asking us what is UW, what is the length of that particular segment. So I've got 4 times 2 minus 1, that's 8 minus 1, I get 7. Okay, and then on part 2, it's asking us how big is YV? Well, YV should also be 7, right? This is very similar to that little patty paper investigation that we hypothetically did in the first video here, that all of these triangles are congruent, so this little piece corresponds to this little piece, and they're both 7, which makes this one 7, and so this whole thing should be 14. Let's just double check it. Let's plug 2 in for x on this top piece. So I'd have 5 times 2 plus 4. 10 plus 4 is definitely 14, so it looks like we did it correctly. Okay, so the last part of this particular objective is just leading us into what we're going to do in order to actually prove the theorem. So we just looked at a couple of examples, right? When we're looking at a couple of examples in order to come up with a theorem, it's essentially just inductive reasoning. And whenever I used, let's say, this coordinate proof that I showed you for that very first triangle that we graphed, that was still just one example. Does that mean it works for every single example? Of course not. So The question is how could we prove it? Well, we could try to prove it with a regular two-column proof and try to make some triangles congruent and stuff like that, but we're going to try a new kind of proof. Where could we prove this? And that's going to be in the coordinate plane, which is going to bring us to the second objective, which is what the next video will be about.